Example 4, let the total revenue be TR is equal to 700 minus 3025 over Q plus 7 minus Q. What is the marginal revenue when revenue is at a maximum? What is the maximum revenue? So we're given our total revenue function, and the first thing we're being asked is what is the marginal revenue when revenue is at a maximum? So thinking back to our previous module, let's define what marginal revenue is. By definition, marginal revenue is the derivative of total revenue to quantity. That's what it is by definition. So really, marginal revenue is the slope of our revenue function. So I'm just going to draw some random lines here. And we would expect marginal revenue to be that slope that exists along our revenue function. So when revenue is at a maximum, and we have our highest revenue, so let's look at some local maximums here, a maximum here and a maximum here. What can we say about the slopes in those points? Well, the slopes at those points are 0. Slope is equal to 0. So our marginal revenue, the slope of our revenue function, would be equal to 0. Now be careful. Total revenue could also be a minimum where our slope is equal to 0. But if we have a local maximum, it indeed would also be equal to 0. Now the next thing this question is asking is what is the maximum revenue? What is our maximum revenue? Now, our function doesn't look like what I drew right here, but you can see that we can find where maximum revenue would be by examining where the marginal revenue or the slope of revenue would be equal to 0. Essentially, we're going to return to our process for optimization. So our first step will be to determine our first derivative, that dTR by dQ, or that marginal revenue, given our function we have highlighted in yellow above. Now for me to do this, I'm first going to rewrite my total revenue function so that it's a little bit easier to do the derivative. Total revenue is equal to 700 minus 3025, and I'm just going to take that denominator and bring it up by giving it a -1 exponent. Now doing my derivative dTR by dQ, I look at my first term, it's 700. That's a constant, so the derivative is 0. For my second term, I have the coefficient -3025, so that just goes along for the ride. And then I do the derivative of Q plus 7 to the power of -1. I'm going to use the chain rule here. So I'm going to substitute U is equal to Q plus 7. And then I have F of U is equal to U to the power of -1. So doing my derivative, my chain rule, I'm going to take di F by di U and multiply it by du by dQ. So you can see that those U's cancel out in the end. So doing that here for our derivative, di F by di U, that's the derivative of this portion, will be -1 times U to the power of -2. Of course, my U is Q plus 7, so I'm going to substitute that in. And of course, I'm not done the derivative. I have to do my du by dQ. Looking at the derivative of Q plus 7, I get 1. So now I've done the derivative of my second term. I now have to do the derivative of my last term here, -Q, and for that I get -1. Cleaning this up, I get dr by dQ is equal to, I have my -3025 times -1, giving me positive 3025, Q plus 7 to the power of -2 minus 1. So now I've determined my first derivative. My next step is to set that derivative to be equal to 0 and solve for those Q values. I'm going to move -1 over to the other side by adding 1 to each side. My 1's cancel out here. On the left-hand side, I'm left with 3025 times q plus 7 to the power of negative 2. So instead of writing a negative exponent, I'm going to put it back in the denominator, q plus 7 squared. And then I have is equal to 0 plus 1 here is equal to 1. I'm going to multiply up q plus 7 squared on both sides so that they cancel out on this side. And I'm left with 3025 is equal to q plus 7 squared. To eliminate the square sign on the right side, I'm going to take the square root of both sides of the equation. And the square root of 3025 is 55 is equal to q plus 7. And then finally, I move that 7 over to the other side by subtracting 7 from both sides. I get q is equal to 48. So I know that there is a slope of 0 when q is equal to 48. Of course, it could be in either of these shapes, or it could be a saddle point. But I know that the slope is 0 when q is equal to 48. Now what I'm going to do is I'm going to solve for the associated total revenue value. So total revenue is equal to 700 minus 3025 over q plus 7 minus q. So when q is equal to 48, I get 700 minus 3025 over 48 plus 7 minus 48. And this works out to 597. So I know q is equal to 48. Total revenue will be equal to 597. For our homework questions, if it asks you to solve for a maximum, you can skip the second derivative test for the benefit of time. But to be thorough here, if I were in the workplace, I would do my second derivative test to confirm that this is indeed a maximum. So the next thing I'm going to do is to do my second derivative test, steps 4 and 5 here. So I know that dtr by dq is equal to 3025 times q plus 7 to the power of negative 2 minus 1. That is what we had determined over here. Now doing my second derivative is d squared tr by dq squared. So I'm going to do the derivative of this first term here. I have 3025 as the coefficient. It just goes along for the ride. Then I'm going to do the derivative of q plus 7 to the power of negative 2. Again, using the chain rule, u is equal to q plus 7. Therefore, f of u will be equal to u to the power of negative 2. For the chain rule, I need df by du times du by dq. Df by du is going to be negative 2 times u to the power of negative 3. Again, I'm going to substitute that u is q plus 7. So that's the first part of the chain rule. Now the second part of the chain rule, du by dq. Well, for that, the derivative is simply 1 in this case. So putting that together under my second derivative here, I have negative 2 q plus 7 to the power of negative 3. Lastly, I need to do the derivative of this negative 1. It's a constant, so the derivative is equal to 0. Cleaning this up, I get d squared tr over dq squared is equal to negative 6050 times q plus 7 to the power of negative 3. Now the point of this second derivative is to see what the shape of our function is at our q is equal to 48 value. The one that we determined earlier is where there's a slope of 0. So I'm going to substitute that into my second derivative here. Q is equal to 48. I get negative 6050 times 48 plus 7 to the power of negative 3. And I get negative 0.03636. Now this is a very small value, but what we're focusing on here is the sign. the sign is negative, indicating that over this region it is indeed concave down. So when Q is equal to 48, we're in a concave down region where the slope is 0. That indicates that we are at a maximum. So now I have confirmed that we are indeed working with a maximum, and we know that the maximum revenue is equal to, and we solved this earlier right here, 597, and it occurs when Q is equal to 48. So now we're done the optimization part of this problem. Let's move on to the graphing. So next I'm going to solve for my intercepts. Recognizing that we're going to be graphing Q versus TR, where TR will be on the horizontal axis, there's going to be two types of intercepts. There's going to be the easier to solve for vertical intercept, so that's going to be the TR intercept because that's our vertical axis. And that occurs when Q is equal to 0. Along this line here, Q is always 0. So we take our original total revenue equation, 700 minus 3025 over Q plus 7 minus Q, and I substitute Q is equal to 0 into that equation. So then I'm left with 700 minus 3025 divided by 7, or 432.14, giving me 267.86. So getting an idea for scale on our vertical axis, I know that our maximum is going to be at 597, so I can set a maximum here maybe at 600. This would then be 300. Dividing that into thirds, I get my 100 and 200. So 267 would be somewhere around here. So now let's think about our horizontal axis right here. Those Q intercepts will happen when TR is equal to 0. So this time I take my equation right here and I set TR to be equal to 0. It's equal to 700 minus 3025 over Q plus 7 minus Q. And now I've got to do the tricky work of isolating or solving for what Q is. So I note that I've got a denominator in one of our terms here, so I'm going to give everything a common denominator. So I have 700 times Q plus 7 over Q plus 7 minus 3025 over Q plus 7 minus Q times Q plus 7 over Q plus 7. That's just to give everything a common denominator. So now I have 700 times Q plus 4900 minus 3025 minus Q squared minus 7Q, all in my numerator, over Q plus 7. Now, as noted in the earlier examples, our denominator can never be equal to 0. So we can rule out Q can never be equal to negative 7. Q can never be equal to negative 7 because that would give us a denominator of 0, though we kind of already ruled that value out as we're dealing with quantity and we don't have negative quantity. But what I can do is I can just eliminate this denominator in this assessment because this is not what's going to turn this to be equal to 0. It's the numerator that has to be equal to 0. So now collecting all the terms in my numerator, I'm going to start with my Q squared term here, negative Q squared, check. Then I'm going to collect my Q term, 700Q minus 7Q, I get plus 693Q. And then collecting 4900 minus 3025 leaves me with 1875. What I can see is that I have a quadratic here. I have an exponent of 2, then I've got a Q term, and then I've got a constant. So I'm going to use the quadratic formula to solve for Q. So Q will be equal to negative b plus or minus b squared minus 4ac, all square rooted, over 2a, where my a value is my coefficient for Q squared, negative 1. Negative is important. My B term is my coefficient for Q, 693. And my C is my constant here at the end, 1,875. Putting this all into my quadratic formula, I get negative 693 plus or minus 693 squared minus 4 times negative 1 times 1,875, all square rooted, over 2 times negative 1. This gives me negative 693 plus or minus the square root of 487,749, all over negative 2. Working out that square root, I get negative 693 plus or minus 698.4, all over negative 2. So now when I do an addition here, negative 693 plus 698.4 divided by negative 2, the result is negative 2.695. Now our Q values can't be negative, so this is not possible. So let's try for the other Q value. If I subtract my 698.4 instead, and this gives me 695.7. So I have an intercept where Q is equal to 695.7. I expect my total revenue to be equal to 0. So coming back to our graph here, we would graph it maybe all the way to 700. So I know that at 695.7, right around this 700 value, I would have an intercept there. The other key point that I would have is my TR max when Q is equal to 48. So that's going to be right around here. My maximum is right around 48. And my TR max is close to the 600 over here. So it'll be right around here. Just doing a rough sketch. Now this is a tough line to draw right now. And it's partly because of my scale, I'm guessing. We see something like this. A very sharp increase at first, and then it might drop. Let's confirm that this is indeed the shape everywhere. Looking at our second derivative, we've already calculated, I'm just going to pull it up. We can see that it was negative 6,050 times Q plus 7 to the power of negative 3. We know that our Q value is always positive, so this term here is always positive. A positive value raised to any exponent, it doesn't matter, it's always going to be positive. And this value, it's a coefficient, it's a constant coefficient. So we're always going to have a negative times a positive. We know that our second derivative is always going to be negative, so we do know that it always has this concave down shape. So overall, we have a general idea of what the shape of our graph is going to be. It's going to look something like this. So let's compare this to the graphs we were given in the handout. So looking at these graphs, I can see I need one that is concave down everywhere. So that rules out graphs B, C, E, F, and G. So we're left selecting between A, D, and H. Now when I look at A and H, they've got like a smooth dome type shape to them, versus D has a really sharp sudden increase, and then it kind of tapers down. What we looked at when this graph definitely climbs really quickly. But what happens after it climbs is that it could also take on a shape like this. So this could just as well be the shape, but the key part is that it has a really sharp increase at the beginning. And that is in line with graph D. And if you want to take a look a little bit further onto graph D, you can see that the scale only goes to 100, indicating that there's a long plateau before it drops off. This is only a sixth of our horizontal scale. So graph D is the correct graph.